Yeah. So that's just the unique thing about DevOps as a service in Nigeria. And then at the end of the day, you will be grounded with a full understanding of DevOps, the practices, the culture, and the skills needed to be able to transform your workplace so that 6 months from now, a year from now, 2 years from now, you can reflect and be thankful that you have risen up the DevOps ladder. So on behalf of my co-founders, Oladapo and Nuruddin, as well as all the faculty leaders here, I welcome everybody to this webinar. So today is going to be very interesting. So we're going to be discussing infrastructure as code and its role in modern DevOps. So before we introduce our guests, let me quickly give a brief summary of what infrastructure as code is. Now, when infrastructure, as we all know, is to be provisioned traditionally, right? What usually happens is that a ticket would have to be logged, and then someone at the other end, would have to take up that ticket, by clicking and clicking to provision that infrastructure. Now, that was fine and okay, only if that person does not need to manage a very large infrastructure. We all know that, right? But going to the cloud, we all know that the cloud is a different ballgame entirely. And of course, the cloud is predominantly, dominated by APIs and what have you. And what that means is that there's usually higher elasticity in terms of, paying for resources you need at any given time, and then dynamically, scaling those resources up or down based on demand. We all know that. Now, most organizations need elasticity, to be honest. They need elasticity, especially when you are in the cloud, to be able to save resources by dynamically scaling resources up or scaling resources down, when they are not in demand. But of course, doing that manually is very, very prone to human error. So the question is, how do we take this process of manually clicking, to properly provision an infrastructure, or manually scaling up resources up and down, and sort of capture all of these processes in a codified way? So if I need to do this maybe one time, 10 times or 100 times, I can automate that so that every morning I can just quickly write a script to run this, just quickly write a script, run that script to be able to bring up 1,000 resources. And then by evening, I can run that same script to bring it down, right? And now that we have actually captured it in that codified manner, we can now version it. So basically, that is just more like the summary of infrastructure as code, but it goes beyond that, really. And this evening, we are actually joined by someone that is very, very versatile in this field, someone that is knowledgeable about cloud and DevOps, Gbemisola Ojo. So basically, I will just call on one of our co-founders, Oluwaseun, to just quickly give us a brief info of our guest speaker today, Gbemisola. So Seun, if you are there, please kindly go ahead for the brief bio of our guest. Thank you.
Good evening, everyone. I thought you all can hear me. I'm excited to introduce to us a very special person to us, and she's, like Dako has mentioned, she's a well-known practitioner in the DevOps space, and we're excited that she was able to grant she was able to grant the invitation to join us this evening to take on this webinar. Gbemisola Ojo is a UK-based cloud DevOps professional. She has a very vast experience managing cloud infrastructure in AWS and automation of software development processes using CI/CD, continuous integration and continuous development pipelines, and leading cloud migrations projects for Fortune 500 companies. She's a certified AWS solution architect. She has a very strong passion for technology and a transition into moving from mechanical engineering, both our first and second degree, to technology computing space, cloud computing, DevOps, and cybersecurity. She has developed a programming skills independently and continue to gain new set of skills through practical projects and constantly expanding her capacity in the IT industry. She's the founder of Cloudbuster Academy, where she trains individuals to become cloud DevOps professionals alongside other experts in the industry. And in less than 2 years, they've achieved a very commendable feat of training over 100 students who have not only gone on to acquire AWS certification, but they've been able to land amazing jobs, job offers in cloud computing, data science, and DevOps. The vision for the training company is really to be the foremost tech training provider, especially for Africans, aiming to raise 10,000 competent DevOps engineers by the year 2030. Gbemisola is well known for excellent delivery, positive energy, drive, tenacity, strategic mind, and ability to lead teams effectively, leveraging people's diverse strengths to deliver expected business outcomes. On that side of work, Gbemisola is a minister of the gospel, a conference speaker, an independent business consultant, and a serial entrepreneur running businesses in media and hospitality. Gbemisola, thank you so much for honoring our invitation, and we hope we have an interesting session this evening. Thanks so much.
Thank you so much, Oluwaseun. Thank you, Dakbo. Thank you. Please confirm if you can hear me.
Yes,
Yes,
we can hear you.
yes.
Okay,
Yes, we
okay,
can hear you.
amazing.
Very loud.
Amazing.
Okay.
Good evening, everyone, and thank you so much for having me. I have one of my amazing team members, Cloudbuster colleagues on the call, Akiwumi. So thank you for joining, and everyone else who has joined. So everyone that is on the call, I'm really grateful for this opportunity to speak to you. I'm very passionate about technology, so every time I have the opportunity to talk about tech, it's always a pleasure. It's always a pleasure. So so Dapo, how would you want? Do you want me to talk about infrastructure as code first, or we just go straight into the questions and the answers?
Yes. Okay. So we'll just go straight into the question and answer. So so basically, before we actually go technical, right? Because when Sean was taking the bio, he made mention that you actually transitioned from being a mechanical engineer to IT. So in just like a few minutes, just tell us how you're able to do that. Because even within the bootcamp today, we have people that are not actually in tech, and that's has actually been a common question, being asked, like, where do I start from, and how, how can I actually transition from a non-IT background to an IT background, and of course DevOps as you have today. Yeah.
That's a good question, and I must really commend you, Dakwa, and the entire team, for this bootcamp that you set up. It takes a lot of passion, especially if you are now doing it, free of charge. From what I've heard, it takes a lot of passion, dedication, and all to gather people and really want to see them grow. So I really must start by commending you. So talking about transitioning, some people mix technology. Some people believe that once you've done a STEM course, everything is tech background, but it's not true. Engineering is completely different from technology, right? I only did one coding language when I was in school, and it was a very old language. Let's not even go there. And I don't remember using computer for it. I think we just wrote down some codes with our hands. So you don't even know whether it's working or not. So I wouldn't consider that a tech background, So
Yeah.
I want you to know that regardless of what you studied at university or what you did as your background, whether you've not even gone to university yet, you can learn technology just the same way you can learn anything. Like, everything can be learned, everything can be understood. You're not dull. No human being on the surface of the earth is dull. You may just be a victim of maybe education, maybe wrong teachers growing up, and wrong notions about things. But as long as you have made up your mind, there's a quote by Thomas Edison that says that whether you think you can or you think you cannot, you are right. So if you think you can learn DevOps, you are correct. If you think you cannot learn DevOps, you are correct. So it's all about what is on your mind. So I just want to encourage you. We've seen this, and Dakbo can tell you, and the entire team, they can tell you over and over again. We've had people come to our bootcamp, background in English, dentistry, completely different fields, and they've transitioned into technology. So I moved from mechanical engineering because I got a tech job. I was privileged to get a job, and I learned on the job. I learned all my cloud and DevOps skills on the job. But not everyone has the opportunity to learn on the job. Not every organization will take on somebody with potential. So that's why we've set up boot camps. Dakpo has this boot camp that is running. If you're signed up for it, just take it very seriously. There are many training programs out there. If you want to transition into tech, I would definitely recommend a structured training program, just like what Dakpo is doing and the team right here. So your number one way of transitioning into tech is to actually sign up for a program, a comprehensive program that can take you on that journey, and then take it seriously and then begin to look for job opportunities so that you can solidify your skills.
All right, thank you so much, Gbemi, for that. Okay, so to start, right, there has been this buzzword in the IT space today, and virtually everywhere you go, on LinkedIn, you would definitely find a sysadmin person, right, doing DevOps, right? You would definitely find someone that's, that's gone to the sysadmin part doing DevOps. So what really is DevOps? Or let me say, what really is modern DevOps?
Amazing. Again, very good question, because we get asked this question a lot. What's this DevOps thing all about? It's very simple, and I'll try to break it down in very simple terms. DevOps is a combination of two words, dev and ops. The dev means development team, and then the ops means operations team, right? Before we started using DevOps as a buzzword, what used to happen in tech is, if there is a software to be built, for example, let's say you want to build an Instagram. I mean, sometimes we forget that there were times that Instagram did not exist. People had to sit down and come up with the idea and start building
Absolutely.
it. So let's say you want to build an application like an Instagram or an X or WhatsApp, so people need to sit down and then plan. And then after you plan that, you develop it, you build that application. The people that develop and build the application, these are people that you call software developers. You call them so because they actually write code. These are people that understand Java, Python, and all of these things, because their own responsibility is to write the code that makes the application work. Now, operations team are the people that ensure that the code is working according to plan. They are the ones that do all the monitoring, the logging. They are the ones that do all the software patches. If there needs to be an upgrade in the code, or if there needs to be an upgrade in the infrastructure where the code is sitting, all of this sysadmin work, just like Dakpo was saying, all of this operational, just like the word operations, right? Anything that ensures for the smooth running of that application, that falls under the operations team. So from what I'm saying, I'm sure you can bear witness that both the development and operations team are very important. But previously, before the concept of DevOps, these two teams used to work in silos. What that meant is that developers don't know what the operations team is. The operations team don't know what development team is doing. It's only when all the coding is done that they pass it on to the operations team, and then they begin to test if it's working, and all of that. So with the concept of DevOps, it's the idea of DevOps is a cultural change, which is that instead of these two teams or two groups of people working in isolation, let the development and operations team work together from the beginning of when you are building the software, all throughout the software development life cycle. And that's a very simple statement. Software development life cycle is your plan from the beginning, as a way you're thinking about the idea, to when the software is actually in the hand of the end user. So the concept of DevOps actually integrates the software development and the operations team, and this improves collaboration, and it also helps to deliver software more effectively. Now, in order to make this integration between the development team and operations team go really well, that is why they carved out this concept of having DevOps engineers. So DevOps engineers are people that actually enable this way of working. So there are a number of tools that you need to use to ensure that development and operations team are working together effectively. Let me give you another analogy. It's just like, let's say, for example, you're baking a cake. You want to bake a cake, right? And with a cake, there's always the actual cake batter itself, and there's a decoration on the cake. So you can look at the actual cake batter as like the development team. These are the people that are responsible for actually mixing the egg, the sugar, the butter, the thing that actually makes up the cake itself. Now, when it comes to now decorating the cake, ensuring that the cake looks the way the customer ordered it, that one, you can liken it to the operations team. So when we say that, okay, let's not have a different person bake the cake and a different person decorate the cake. Let whoever is baking and decorating the cake, let them work together all throughout the process of baking the cake to avoid errors. To avoid, this part of the cake was meant to be chocolate cake, now you put vanilla. Do you understand? So the concept is just that let these two teams work together, the development team and the operations team, so that software development or software delivery process will be it will go, it will happen more effectively, and we can go on and on about the benefits of it, but that's the whole idea. Development and operations, and we carved out the need for DevOps engineers, and then there are a number of tools that we'll talk about it later today, but there are a number of tools that DevOps engineers now need to know so that you can enable that culture of nobody's working in silos, while ensuring that development, operations, everything is happening at the same time, and the software development process is seamless. Because I hope
All right,
it's
thank you.
a bit clear.
Yes,
Yeah.
of course, yeah. So I usually tell people that DevOps is a unifier of both the dev and the ops team. And I love the choice of words you used, collaboration and culture, which is very, very important, even before jumping on tools, because most DevOps practitioners that you see today are just all about tools. Let me just learn all the tools I can learn, Terraform, Ansible, without even having that mindset of what DevOps is. So thank you so much, Gbemi, for that concise explanation. So let us talk about infrastructure as code. So can you just explain infrastructure as code? Because it's like most people are actually very, very confused. And the first thing that actually comes to mind is Terraform, infrastructure as code and Terraform itself. So can you just explain what IAC means and why it's very, very crucial, why it's a very, very crucial practice in DevOps?
Yeah, I mean, infrastructure as code is a part of DevOps that I personally really enjoy. Like, infrastructure as code, what does that mean? When you're working, I just give an example of building a software, right? If you need to build any software for that matter, that software must reside on a server. It can be a virtual server or it can be a physical data center, but there has to be a computer that is powering that application. Now, this computer that is powering that application is part of what we refer to as the infrastructure behind it. So that's your infrastructure, that's your application infrastructure. Now, your virtual server or your data center, because this thing is in layers, right? When I say your physical servers, it's just think about the fact that you have your phone, right? So you have a physical phone on your hand, and then your phone has an operating system. It can be an iPhone, it can be iOS operating system, it can be an Android operating system. The same thing with a laptop. You have a physical machine, but what differentiates your laptop is operating system. It can be Mac OS, it can be, Windows and all of that. And then you now have applications that are installed on that operating system. You need to understand these three layers of computing to understand infrastructure as code. So you have your computing, you have your physical hardware, which is your phone, your laptop, your server. That's your physical hardware that is hosting an application. Your physical hardware always has an operating system installed on it, and the operating system now is what powers the application. And that's why you can have an application running on multiple operating systems. Everybody uses WhatsApp. WhatsApp can run on Android, it can run on iOS, and so on and so forth. Let me not go deep. Now, the concept of infrastructure as code is that your infrastructure, the virtual server that is powering your operating system, powering your application, you now want to configure that everything that has to do with building that infrastructure, you want to have it in code format. What does code mean? I mean, I don't know how many people are technical on the call, but coding is your lines. I mean, you can create your application by, for example, if you are using AWS as your cloud provider, if I'm building a cloud infrastructure and you're using AWS as a cloud provider, one way to build your virtual server is to go into AWS and begin to click, I need a server. I want it to be a T4 large server. You decide, okay, what's the gig of the server? You can decide, what kind of operating system do I want on this server? You can choose all those things by clicking different buttons on your AWS console. But when we talk about infrastructure as code, instead of me going into my cloud provider or going into wherever I'm setting up my server, instead of me going to go and start selecting options, I want to write my infrastructure as lines of code, right? So your infrastructure is basically, you have it written as lines of code. So it is written in text format. Every information about your infrastructure is written in text format. So what that means is that every resource that you need, every configuration that your server needs is written in text format. If you want your server to have 60 gig RAM, you write it as a text format. If you want your server to have so subnet or be in this availability zone, everything is written as a text format. The benefit of that let me just tell you one simple benefit of that is reusability. So we now have all of this application, all of this, ISC tools, just like what Dapo was saying, that enables this. An example is Terraform. So let's say, for example, I'll have gone into AWS and create a virtual machine and I click some buttons, I chose some different selections. Maybe I don't even remember what I chose. Now I have a server that is running very fine. If I need to go and create that exact server again, I need to remember every single thing I selected to get that server. But guess what? If what I did was to use an infrastructure as code tool to spin up that server, which means that I wrote all the configuration that I wanted for the server in a text format using an ISC tool like Terraform. If I need to create that single server 100 times, all I need is my Terraform template. Once I have my Terraform template, I can spin up one server, exactly the same configuration, use that same template again, spin up another server with exactly the same configuration. So that's what infrastructure as code means. All the details, all the information that I need for my virtual server, I'm writing it in a text format. In a particular infrastructure as code tool. It could be Terraform, it could be CloudFormation and all of that, such that if I need to rebuild that infrastructure again, I always have it in text format. I can use it as many times as possible. That's the best way I can explain. I don't know how technical the people. Can you let me know if you understand what I'm saying? Can you just put a yes or a no or in the chat box so that I can know, if I'm engaging you? Can you put a Y or and oh, okay, that's encouraging. I can see a few people. Oh, that's good. Thank you, Dapo. Let's go to your next question.
We're actually very technical, actually, so you can
good.
You can be free. Yeah. Okay,
Good.
so when you're talking about the key benefits of IAC, you mentioned something very important, reusability. Now, aside from that, are there other key benefits of implementing IAC in DevOps processes? So if there are, you can just go ahead and explain.
Yeah, very true. There are many. I mean, you can do extensive research, but I'll just say a few, maybe like 3 that come to my mind. I already talked about, reusability, and that links to consistency as well, because what you have is that if you need to create a server 100 times, you can be rest assured that if you have used infrastructure as code, you can be rest assured that your configuration is exactly the same. Then another benefit is the fact that there's minimum manual intervention, and this thing has saved us a lot in the industry. Like, when you have your infrastructure written as code, right? If you need to change anything in the infrastructure, you must change it in the code itself. You can't now go to your server and start changing any information. You have to change the code and then redeploy it. So that helps to reduce the risk. It helps to reduce a lot of manual intervention on a live server, because everything is controlled centrally from your code. So there's a lot of reduction in risk of not remembering what change you made to your server, because all the changes must go through your code. Like, this has happened to me many times in the industry, because I mean, all the places I've worked, we've used infrastructure as code extensively, and if you need to make any change to the server, you have to change it on the code. And when you change it on the code, you even need to get a pull request. Somebody else needs to look at it. Yeah, somebody else needs to approve the PR. Somebody else looks at it, they approve the PR, and then you merge it, and then we'll now redeploy that infrastructure. So you can't just go into a live server and start changing it or increasing the size. We can't do that. So it really helps to control, it helps to reduce manual intervention that would have happened, on the virtual server itself. There are things around security as well, because, everything that you're doing is controlled from somewhere. So everything you're minimizing risk, you're minimizing undue access to your infrastructure, because everything that you are doing on your infrastructure, in fact, if nobody has direct access to your I'm using cloud because I'm more familiar with the world of cloud. That's, you can have physical data centers and actually do infrastructure as code as well, but I'm just talking in the context of cloud. So in the context of cloud, you don't even if nobody in your team has access to the AWS account where your virtual server is, nobody needs to have access. Everything is just controlled in your Terraform or your CloudFormation template, which is stored in a GitHub repository or a virtual control system. So any change that is being made, nobody can just log into your AWS account and start changing anything about your server. All they need to do is to change the infrastructure as code. And within the infrastructure as code, there must be pull requests. So you can put things like pull requests and all of that. So that way you can easily control things going wrong. You can improve the level of security, accountability as well. I really love this part because when you're using infrastructure as code, it's easy to trace who did what. I just explained to you most times when we've used infrastructure as code, we've used it in conjunction with a version control system. Even within some of them in themselves, you can tell, okay, somebody added this line to this Terraform template. So if anything should go wrong, because if all you have to do is to go and change the server itself, sometimes, unless maybe you have features like CloudWatch and CloudTrail and all of this, that's when you can tell who actually changed something on the server. But I mean, there's a condition to that. But my point is, there's improved accountability when you're using infrastructure as code because, you can tell who made a change, who added something to this, who enabled a security group. These are all things that you can do with your Terraform template. Any change you need to make to your infrastructure, you want to change the security group, you want to open this, you want to close that, you want to increase the size of this, all of that is done in your code. And we can know who changed it. And you can easily roll back. Let me add that as the last advantage. You can easily roll back if there's a problem. You can go back to a previous version of your infrastructure as code and then redeploy it. We've had to do that many times. So those are some of the advantages that comes to mind.
Thank you so much, Gbemi. So you mentioned minimum manual intervention, minimum risks and undue access, accountability. Now, when you're actually talking about accountability, I actually remembered, sometimes ago where someone, in a Nigerian IT space, they will say that someone cooked beans and nobody was actually able to trace who did what. And of course, when you actually mentioned accountability, that was the first thing that actually came to mind. So that's very, very important. And then the last thing you talked about, easy rollback, which is very, very important. Okay, so moving on now, based on your experience, because you're actually very, very vast, in the cloud space. So based on your experience, could you share some real world examples of how infrastructure as code has improved development and operations collaboration within organizations?
Yeah, I mean, there's so many examples. I'll try and give one. There was a time I was implementing open banking, for one of the biggest banks in the UK. And, we had initially, for that particular client, they were not very accepting of the concept of cloud. So what they told us to do is that we should do our development on the cloud and then we should leave their production environment as data centers, so we now had, there's a lot to say about this project, but let me just stay focused on infrastructure as code. So basically you build something on the cloud and then you now deploy into production on premise, but it was fine. I mean, there are that's the whole concept of DevOps and all of this concepts anyway. So we're able to do that seamlessly. You can easily do that as long as, both parties are the same. So now one of the things we needed to do was to replicate all the infrastructure that they had as data centers. We needed to replicate that on the cloud. This is where something like infrastructure as code comes in. So for this particular project, they were using, they had physical data centers and then they had different applications installed on it. I'll just call 3 of the applications that they installed. So for one of the data centers, or for one group of servers, because it was not just one server, for one group of servers, they had OpenShift installed on it. I don't know if you guys have done OpenShift. OpenShift is very similar to Kubernetes, use it for container management. So they had OpenShift installed. On another set of servers, they had RPG installed on it. On another set of servers, they had RPG is for API management. And then on another set of servers, they had data stack. Data stack, is that the name? Data stacks or something? I can't believe I forgot. I have this education in it, but it's been a while. Anyway, they had this data with Cassandra data stacks, installed on it. Yes, that's the name. So Cassandra data stacks was installed as their database. So they had this thank you for the comment. So they had these 3 solid applications running on multiple servers. So one of the things that we needed to do was to replicate what they had in data center onto the cloud so that we can build our development environment and continue to build code for them and deploy it into production. So in order to make this happen, imagine having like 5 data stack servers, 6 OpenShift servers, and 7 RPG servers. Now, without infrastructure as code, all those maybe 20 servers altogether, in order to build that, by the way, I'm just simplifying it. But my point is, in order to build that, imagine if you had to create the server one after the other. Okay, this one is OpenShift, though. You will now go and configure, this is the size I want for OpenShift, server one. Second server, what is it supposed to be? RPG. You now go and configure RPG on it. The third server, what's it meant to be? Oh, another OpenShift server. You now do that manually. Imagine doing that for 20 servers, for 100 servers. Of course, we did not do that. All we needed to do is to understand, okay, what are all the configuration that they have on their OpenShift server in the data center? So once we got all the configuration, okay, this is the size of the server. Okay, this is the operating system is running on. Okay, this is that. So we just got all of that and we wrote it as code. We use CloudFormation in this case, so we wrote it. But the truth is, if I'm being very honest and I give you the full picture, the truth is we actually had to go and build it first manually to ensure that it was working. And then when it's working, when we noticed that it was working, we now went back to write the code, that made it work. So there was a bit of reverse engineering there, because you also cannot just go and be creating templates. You don't know what you're going to do. You understand? So we had to first of all understand the configuration that they had on premise, and then build it on the cloud. And then from what we had working on the cloud, we now go back and write the CloudFormation templates. From that CloudFormation template, we deploy it again. Is it similar to what we created? So I've deployed an OpenShift server manually based on what I've seen on the data center. Okay, now I've written a CloudFormation template that has the exact configuration of that OpenShift server. I deploy that CloudFormation template again. So I look at the OpenShift server, everything is working fine. Now I'm confident that the template I have, I can use it to deploy as many OpenShift servers as possible. So I cannot go back and say, how many OpenShift servers do they have on premise? They have 10. Just one template, I cannot use it to deploy 10. Do you understand? The same thing we did it for RPG, the same thing we did for the other data Cassandra database, and with the way, by the time you continue to work on infrastructure as code, you even realize that there's just a lot that you can do. You can get to a point where you even automate, you can create 100 servers, and then within those 100 servers, you can now specify that, okay, 5 of it, OpenShift to be installed on it. 12 of it installed data stacks, So this is an example of a practical time that we used infrastructure as code.
Yes, very, very apt. Very, very apt. Okay, so talking about the tools in IAC, you mentioned Terraform, you mentioned CloudFormation. What are some other popular IAC tools and frameworks, that DevOps teams commonly use, and what criteria should organizations consider when choosing the right tool for their needs? I think you're muted.
Oh, sorry. Yes, I'm muted. Yeah. So for me, if I'm to choose, Terraform is the most versatile that I've come across in the industry. If anybody has a contrary opinion, please, you can put it in the chat box. Let's know. But there are so many of them. There's Chef, there's Puppet, there's Ansible. Now, the good thing about all this infrastructure as code tool, what I've found out is that at the end of the day, most times we get to use a mix of multiple tools, depending on what you're trying to achieve. And if you really want to take advantage of the strength of each tool, one of the things I really like about Terraform, for example, is the fact that there's multi-cloud deployments in Terraform. You can have a Terraform script and deploy it into AWS. That same script can deploy it into GCP. That's very powerful. CloudFormation, for example, is another IAC tool, but it's specific to AWS alone. The same way, cloud providers have their own. So, for example, I know that there is Azure Resource Manager for Microsoft Azure, which is similar to AWS CloudFormation templates. And then there's also Google Cloud Deployment Manager, which is similar to CloudFormation templates. So as you can hear, for Azure Resource Manager, that is specific to Microsoft Azure alone. AWS CloudFormation is specific to AWS CloudFormation alone. Google Cloud Deployment Manager is specific to Google Cloud alone. So Terraform, however, is versatile. You can use it for multi-cloud. You can use the same Terraform template, use it on Azure, use it on Microsoft Google Cloud, use it on AWS. So if you're trying to make a decision about the best tool to use, it always starts from the problem. What exactly are you trying to solve? What are you trying to automate? I mentioned Chef, Puppet, Ansible. I've used Ansible more within that category because sometimes they mention those three together. And Ansible is actually, and I teach Ansible, is one of the modules I take at Cloud Booster, so because I don't teach all the modules, but I teach Ansible, so for Ansible, one of the things we say about Ansible is that Ansible is a lot more specific for the configuration management, so which means that, for the software that you are deploying on your infrastructure, all the details that you want within that software, Ansible is very good for the configuration management, so while you can easily use CloudFormation, Terraform, and all of that for infrastructure deployment, you can use Ansible, is better used for configuration management. You can use Ansible for infrastructure deployment as well. But the point is that's why I went back to, if you're trying to decide what tool do you want to use, always start with what problem am I trying to solve? And then which of these tools works best? As much as possible, don't use too many. Don't use too many. If you're using CloudFormation, there's no point of using Terraform again. Pick one between Terraform and CloudFormation. You can combine Terraform with Ansible. You can combine CloudFormation with Ansible. Everywhere I've worked, we've always had to use a combination, but I would recommend that no more than two. So we know that Ansible is very good for configuration management. We know that Terraform is multi-cloud and is very good for infrastructure deployments. Narrow down to those two. And let me also be honest, there are also other factors that determine what tool you use. So we've talked about just a side of it, which is technical side of it. Sometimes, there are larger issues within the organization that actually causes for an organization can have a bias, a particular infrastructure as code vendor can have a deal with an organization that they cannot resist, in the case if it's not open source, so in that case, you have to think about things like cost as well. Are there cost implications? Most of these things are actually open source, so there's no cost implication, so. Well, I'm just saying, let's be aware generally when it comes to software selection, tool selection, as much as you want to use the best, sometimes the organization might have a bias towards a particular tool. If it's a paid tool, you might need to consider cost. You might need to consider, okay, are there other packages, that the organization already has a deal for? So the technical side is very important. In the case where there's money involved, you need to think about the cost as well. You need to think about integration with existing things. Most organizations already have their own existing platforms. They already have their own existing platforms. So if you're going to start introducing infrastructure as code, if it's not something they've done before, you need to be sure that whatever it is that you pick can integrate well with everything that is already going on within the tech infrastructure in the organization. And I hope that is clear. So
yes, that's clear. Okay, so someone is asking me a question, but we're going to take questions later. So quickly, I think, was it not last month, Terraform actually went premium, right? They went from being open source to premium, and then all of a sudden you started hearing OpenTF or OpenTofu. So what's your view about this? Have you used OpenTF? Is it the same thing as Terraform, or there are differences in the operations? I don't know if you've actually used OpenTofu before.
I haven't used it. I've only used the open source Terraform, so I haven't used it. But what I would say is I always like it when some tools begin to go commercial, because that's just my own personal view, because I just feel like it means that they are promising to deliver better than anything that they've had before by the time they start charging for it. Because for you to be able to convince people to choose your own paid tool over other open source tools, it means that you want to start paying more attention to the quality. The truth is, we've actually had a lot of issues with open source applications. Open source applications, sometimes, of course, we use a lot of open source, but one major challenge with open source tools, that we faced a lot is vulnerabilities, because everybody's contributing to it. In fact, there was a time I had to deal with, I needed to Dockerize an application, I think it was about 2 years ago or so, and I didn't have any other choice but to use, I had to download a Docker image I had to download an open source Docker image of the application I was trying to use. And we had so many vulnerabilities. It was so bad. we will use vulnerability scanner. They will say this amount of bugs are in the code, this amount of this. You will try to fix it. It will say, okay, out of 200, 150 has been cleaned, 50, there's nothing that can be done. At some point, you actually have to use the code with the vulnerabilities, but at least everybody knows that there's vulnerabilities in it. So sometimes these are the challenges that comes with open source. And when we say open source, it's free softwares that you can that you can download online and anybody can contribute to it. So that those are because of the nature, it's a good thing, it's a good idea for you to have a code that anybody can contribute to it and you can download it free of charge, but it comes with its own challenges. So Terraform making that decision to go commercial, I believe, is a good one, because that means that they get to monitor very closely who is contributing to Terraform, and they take responsibility for whatever it is that is going wrong if you are using Terraform. So I haven't used the premium version, so I can't comment on that. But one thing I know is that the general concept of wanting to charge, for the use of Terraform, I think is a good thing, because it's a call to them delivering a greater quality. You will see, if they take it seriously, most likely you see a lot more features being reviewed. Now you have people that are actually employed to build Terraform, to research the best practice, to put in their best into the development of this infrastructure as code too. So I think it's a beautiful thing. And if I can just take the question, do you want me to take the question in the chat box?
We would have time for questions, so that I can just finish all of them. Yeah, exactly.
Okay.
Yeah. So are there other playgrounds to try out Terraform, or it's compulsory for me to actually register on Azure, AWS, or GCP before I'm able to try Terraform? Are there like playgrounds, for people that don't
I
want
believe yeah, there are. And you guys, you can correct me if I'm wrong, Dakwa. I'm sure you know the answer to that. I believe so. Even on your laptop, you can install, from what I know, you can actually install it, and then you can test your scripts. You can test, because you need to know, there's a way to, and that's something I like about Terraform. You can actually validate that your script is fine, is working okay, before you deploy it into any environment whatsoever. So yes, you can definitely play around with Terraform, offline,
offline.
and be sure that the code is written properly. Yes.
Okay. So how does IAC fit into the CI/CD pipeline, and what role does it play in ensuring continuous delivery and deployment of applications?
I mean, it's a very good question. And, the concept of CI/CD, I mean, it's a whole topic entirely, but, yes, IAC is a very important part of CI/CD. The two can really, really go hand in hand, because when you have the idea of continuous integration and continuous deployment is that you want to constantly be able to update your code. Let's say there's a new feature that comes in, for example, I always give the example of WhatsApp, because we all use it. The WhatsApp, I was telling someone the other day that the WhatsApp you started the year with is not the WhatsApp that you have right now. WhatsApp has so many, they keep releasing new features. That's CI/CD, because, they keep improving, continuous integration, continuous improvement, continuous delivery, and without you even knowing. That's the beauty. You don't even know. You just wake up and you see communities. You just wake up and you see that, oh, wow, you can do screen sharing. You just wake up and you see all these things. You see nice colors where you make a voice call, and it's so beautiful to look at, so, but my point is this, so both of them really go hand in hand, because when you have your infrastructure in code format, you can easily integrate that into your CI/CD pipeline. So let's say you create a CI/CD pipeline, and the function of, just like somebody's asking the question offline on the chat, let's say you create a CI/CD pipeline, and as part of that pipeline, you actually want to you want to create a server, you want to create 10 servers, and then install different things on it. That's where CI/CD comes in. So you have, usually a CI/CD platform is Jenkins. An example of a CI/CD platform is Jenkins. You can have Terraform integrated with your Jenkins, such that you create a Jenkins pipeline, and then you say, okay, Jenkins, you can even integrate it with GitHub. You can say, Jenkins, pick up this Terraform script from Git and then deploy it into AWS. And the next thing, you have 10 servers being created with different things installed on it. So the beauty of actually, I feel like one of the ways to really, really enhance the functionality of infrastructure as code is to use it as part of your CI/CD pipeline. That way you have a lot of automation in place. You want to create 10 servers. Now you're not even going to now manually say, okay, I need 10 servers and all of that. You just have your Terraform script, you've written all the instructions, and then you put it as part of your CI/CD pipeline. If you're using Jenkins, you can, and you've integrated your Git with your Jenkins, have your Terraform script stored in a GitHub repository. Jenkins goes and picks up the script and makes the deployments. That's your CI/CD. being integrated with infrastructure as code.
All right. Thank you so very much. Okay, so one last question before we go to the Q&A. What are the best practices for writing? Because of course, when we're talking the other time, you mentioned scripts, templates, code, and whatever. So what are the best practices for writing and maintaining IAC scripts or templates, and how can teams ensure the reliability and security of their infrastructure code? Do I just store scripts on GitHub or on Bitbucket, my TF scripts and whatever? So in terms of best practices and ensuring maximum security, how can teams, ensure that this particular process is done properly?
Yeah, I like the question. So to ensure that things are done properly, my first thing is there has to be a lot of thinking. Sorry, excuse me. There has to be a lot of thinking and planning ahead. When you're automating and I'm tying it to security now. Number one best practices, let me say planning for a secure deployment. Let me put it that way. And what I mean is this, you want to, or let me even say access control. Let's start with access control. Number one thing you need to think about is how many people actually need to be able to access, how many people are going to, how many people are involved in this project? How many people do I need to give access to my Terraform scripts? So upfront, there's something in tech that's called the principle of least privilege. The whole development team does not need to have access to Terraform code if they have no business with it. There's not needed. Because this is where you now find out that, there's an intern, somebody that is just learning that they've gone to delete everything, everybody's panicking. So as when you're building whatever you're trying to automate an infrastructure, you're trying to convert all the infrastructures you have in your organization into code, think about how many people really need to access it. And what do they need to be able to access? So number one, control the access. Think about access control as part of your security, as you are doing your infrastructure as code. So don't give everybody access to the Terraform scripts. Every tech platform that we have these days has a way, there's a whole logic and technology behind access control. You can manage who has access to what. And even when they have access to it, what level of access? Not everybody should be able to delete your Terraform script. Not everybody should be able to edit it. Some people only need view access. Just the same way you have your Google Doc and your Google Drive. Some people only need view access. Some people actually need edit access. Some people, they can edit it, but they cannot delete it. Do you understand? So you need to plan upfront. How many people do we actually need to have access to this infrastructure, to this code? You need to think about it. Who is allowed to do what? This is where you talk about your access. So all these things I'm saying has to do with access control, privileges, granting. Always have, as a best practice, have it at the back of your mind, the principle of least privilege. It's better you deny, it's better you deny everybody, always deny all first. Nobody has access. Then when they need access and they come to you as a DevOps engineer or they request it, now think about what level of access does this person really need? If you just want to look at the code, that's fine. You can even put expiry. Depending on whatever access control tool you're using. Since the person is only viewing the code for for 5 hours, just give them 24-hour access, revoke the access afterwards. You have to keep an eye on who is actually accessing the code. This helps to avoid accidental deletes, accidental edits and, spoiling your infrastructure and all of that. That's the first thing. Another thing that is very important to do, which I already started talking about it when you asked the question of, can you use Terraform offline? There's something we call static code analysis. So when you write your code, there should always be a way to test it, that if it's going to work, without you actually doing a deployment into an environment, without you going into AWS to actually now begin to check. There should be a way to test. It's part of what we call static code analysis. So if you have tools that you can use for static code, when you write your template, just test it first. Test it. Some of them have inbuilt ways. Terraform, I believe, I've used Terraform before, even though it's been quite a while. I've been off technical work for a while, which, but I'll just keep talking from what I've done before. But anyway, with Terraform, there's a way you can test it. You can do Terraform. I know there's Terraform init, Terraform deploy, blah, blah, blah. You can do it before you actually go into a live environment and start deploying your Terraform script. So maximize the concept of static code analysis. Yeah, Terraform plan. Thank you. Terraform plan, Terraform init, and then you do Terraform deploy and all of that. I used to do that. It's been quite a while. Anyways, another thing you can think about as part of your security for infrastructure as code is, yeah, I think you already spoke about it, Dakpo. You were already kind of touching on it. The concept of secret management. Never ever have any confidential information within your infrastructure as code. Leave your infrastructure as code as what it is. It's simply the code that is for your infrastructure. All you should have in your infrastructure as code is your what subnets do we want to use, what's the size of the server, not your access key to AWS. So if you're using infrastructure as code, think about how you're going to manage confidential data. Let me even tell you, there was actually a time that we made this mistake at work. I think it was early days when I was starting as a cloud engineer where, I don't even know what we're thinking. We actually had a lot of confidential passwords and, access to all of these environments inside Git. And, anybody that has access to Git automatically has. I remember the day when our boss called us and said, we're going to change all of this, remove every confidential. And we have to make sure that we migrate it properly such that we also don't lose out on the confidential. I said, never again must we have, confidential data in Git. So my point is, your script should be filled with reusable. Your script should be it shouldn't have confidential data. Let's just put it that way. Anything that is confidential, there are lots of systems to manage secrets. There's a whole thing in DevOps that is just secret management, where you can use Vault or you can use AWS Secret Manager. Yes, so in that, the best practice is to have a separate way of managing your secrets, such that you can now ask, if you're using a CI/CD pipeline, the beginning of the pipeline can be retrieve the confidential data from Vault and then add the confidential data into your Terraform script and then deploy Terraform, which is why most times you eventually use a pipeline, because there are a series of activities that needs to happen. You don't want to keep your confidential data randomly in, some people are not even comfortable. You can actually put your confidential data in your CI/CD tool, but some organizations are very strict on security. Everything that is confidential data must be kept. I remember there was a bank I was working in, Capital One. I remember, there was a central way of managing anything confidential. It was a system that was developed within the bank itself, and you had to understand it was a vault system. So anything that we build, you have to first of all call the vault, retrieve the data that you need, and then you understand the secret that so you have to think of how do you want to manage confidential data when you're using IAC tool? Do you want to use a secret manager, a vault, but do not add your confidential data or your secrets into the actual IAC code. It is not good practice. And the last thing I'll just talk about, riding on all of those things that I've said, is separate your environments. Now this is very important. So usually if you're using infrastructure as code, let's know what you are planning to deploy to your development. In your software development lifecycle, you most likely have minimum of 3 environments. Sometimes you can have 4, you can have 5. I've worked in different scenarios. Sometimes you have what you call your development environment, and then you have your test environment, and then sometimes you have your pre-production environment, and then you have your production environment. Some organization will say from dev to test to prod. Some will say from dev to test to UAT, user acceptance testing, UAT environment, to pre-prod to prod. What am I trying to say? When you're building in tech, you would definitely work across multiple environments. So separate your environment that way. Let it not be when you're deploying your infrastructure as code. Let's know, okay, if you're just still working in development environment, let it be clear. You can do your Jenkins or your Terraform in such a way that you select, okay, this script, I just want to deploy it into development environment. Let me see how it's behaving in an actual environment before you now take it into your test environment, before you take it to your pre-prod environment. So these are things that you can really do. And, you have these are best practices that I've seen. There's a lot more. You can research about these things as well, but I'm just talking from my research and my work as well in this field. Let me stop there for now.
Wow, Mimi. I'm not short of words actually. Like 50 minutes of value, of brilliance, of passing information in the best in the, following best practices. This is massive. This is massive. Thank you so much. Thank you so much for honoring our invitation, and then talking about secrets, talking about security. I think one of that part where most organizations actually overlook is the aspect of security, right? So most of those organizations are just doing DevOps, are just setting up, you talked about images, they're just pulling images from different repositories without actually, factoring in security, which is very, very critical. And I usually used to tell, clients that I work with, as well as the place that I work with, I say, look, I'm not going to do anything pipeline if there is no security team working with me, because I don't just want to, pass application to the to production without someone, actually making sure that all of those security procedures are in place. Are my passwords written in plain? Am I storing passwords on, even though it's even private, GitHub, private Bitbucket? Am I doing all of those things? Am I scanning all my images? Like, things that are very, very critical needs to be, vetted by the security team. So the aspect of security is something that people don't really talk about. People just talk about DevSecOps, but they don't actually go, fully into making sure that there was a time in my previous organization that, an application actually needed to go to production. Right, it was ready to go to production, and then I just told them, I said, look, this is not going to production unless we have a report from the security team, telling us that everything we have done followed the best security standard and all. And at the end of the day, it took some time, but it still went to production, because once things goes out, the next thing that they will just talk about is that DevOps, they didn't do this, they didn't do that and all. So, talking about security, I feel is very, very important, that organizations factor in this particular concept. Okay, thank you so much. Wow, we have just 2 minutes. So we'll just take questions. So please, if you have questions, kindly drop them on the chat so that we can just quickly take the questions in like 5 minutes. Hope you don't mind, Gbemi.
No, that's fine. That's fine, please.
Okay, yeah. So
fine.
let's take the first question here. Good evening. Please, if you want to deploy 5 servers and you want each server to have different name like Jenkins server, Kubernetes server, how can you implement that on your Terraform scripts? So, Gbemi, if you can let's go ahead with that.
And this is common to every infrastructure as code tool, because that's the whole idea. You're trying to deploy multiple things, and yet you still have specific requirements for different things that you want. So I'm going to speak generically, not with Terraform particularly, but the general idea when it comes to using infrastructure as code is, if you want to deploy multiple servers, an example of what you can do is this. You can have the names of all the servers that you want listed in a text file. And then you keep the value where you want your server to be named. You can keep it as a variable, so all the information that you want. So it's not even a matter of naming your Jenkins server. You might actually want to deploy 20 servers and say that, okay, these are the details for my server one. My server one, I want the name to be Jenkins, and I want the size to be this. My second server, I want the name to be Kubernetes, and I want the size to be something different. The general way of managing it, and I'm not going to be specific to Terraform alone, is that most times there's usually a separate document where you have all those details of the servers, name of the server, size of the server, blah, 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 blah. And then you have your generic Terraform templates that can actually read the necessary values from whatever the text file is. So I just want you to have a framework that you can work with. So now, depending on whatever tool you're using, whether you're using CloudFormation, whether you're using whatever, even within Jenkins, you can do it. You can integrate it with Jenkins. We talked about using Jenkins as your, to deploy Terraform. Jenkins, you can always have an input file that has all the details that you actually need. And then your infrastructure as code tool is just variables. You just leave it as empty variables that can be replaced, so your values are read. This is how all of them work. Is it Ansible? It's just the framework, So with Ansible as well, just have your variables there. Just leave it as a variable depending on the tool you're using, and then those values are usually picked up from a different input file to replace it. I hope that makes sense. So I'm not going to go into teaching you Terraform in depth right now, but that's the general framework.
Yes,
And therefore you
makes
can add
sense.
to that as well, you know.
Of course, yeah. Okay. So to the next question, is it possible to learn DevOps alone online on your own without a DevOps team with developers?
Honestly, that's a very good question. I always recommend that if it's cloud and DevOps, okay, well, we're talking about DevOps. If it's DevOps you want to learn, the best way to learn is to do, honestly, which is why boot camps are important, because a boot camp that has serious practical side of the work. I always give Cloud Booster as an example, and I know that Dapo is doing a fantastic job with the boot camp that is running as well. But usually, what we do is our theme is that you learn cloud by doing cloud. As you're learning a DevOps concept, the day you're learning about Git, you're going to use that. You're going to use your Git. You're going to create a pull request, ask somebody to approve it. You're going to create your Terraform template, ask somebody to deploy it and all of that. So my point is this: you can learn it alone online, but you won't get the full gist. You'll probably just have a theoretical knowledge. You need an environment where you can test things, because this thing is practical. It's not theory. You're not just learning DevOps because you want to do an exam. You actually want to become a DevOps engineer. You need a real life scenario or a simulation of a real life scenario, maybe within a bootcamp program. That's what you need. So, and you may not necessarily need a team of developers. In fact, when it comes to developers, if you have friends that are in software development, you can ask them, you can be friends with them and ask them, okay, what do your DevOps engineers do? What are the kind of projects that you guys do? Do you do anything open source? Sometimes a lot of these organizations, they actually work on projects that are seen, that you can see the source code online if it's a public project. So you can actually ask about it, and then you can work on it as well. So that's the kind of thing that you can do. I hope that answers. So please sign up for a bootcamp. Don't just say you want to do it on your own. You won't get the best value that way. You need to do a practical bootcamp, and you need to kind of simulate some of real life work experience, real life experience around it, so that you can actually do the work. So
Yes. Okay. So we'll just wrap it up here, because I actually promised 1 hour, but we are way, because I actually know you're a very, very busy person. So we'll just wrap it up here. So for those that have questions, you can just send the questions directly on our Discord page, and I should be able to take it up from there. So thank you so much, Gbemi. Thank you so much for your time. Thank you for honoring
you're
my invitation.
welcome.
I just reached out to you on LinkedIn, and the way you just accepted, DevOps as a Service Nigeria, we are grateful and honored. So I'll just be calling on my co-founder Nuruddin Camilo to just give a brief vote of thanks. Nuruddin, can you hear me?
Hi, Dapo.
Okay, all right, please go ahead.
Yeah. Hi, everyone. Good evening. I must say that, I actually so much enjoyed the session. And I would like to extend my gratitude to every one of you. First of all, for joining today's session. And it's actually very remarkable. And I also appreciate our guest speaker, which is Gbemisola. We are honored to have you. You actually, showed your expertise and also your willingness to share your insights, which we appreciate. And, it's paramount to the success of today's event. And I also extend my greeting to your colleague from Cloud Booster. Thank you for joining us as well. We do appreciate it. And, as you all know, we are all trying to put our contribution into the world of tech, and trying to train people in one way or the other, and which is so much important, because the knowledge that we share out there is invaluable, and it's going to propagate from one generation to another generation to another generation. And at the same time, I would like to thank my partners for their generous support, because without your collaboration, to be honest, this event will not be possible. And I do appreciate your commitment, to also advancing technology and, fostering innovations that is commendable. And finally, my sincere gratitude also goes to our mentees in the bootcamp. I know that you are enjoying it, and, today's section is also an interesting one. So I want to also thank you for joining virtually, for asking your questions, for your engagement, for the discussions and so on like that. Your presence today is also important, especially to the topics that we explored. And my advice to you all is that I will advise that you carry forward the knowledge and the inspiration that you have gained from today's, today's section, especially, getting to know about IAC, getting to know about, the role in modern DevOps, getting to know about how easy it can be for you to transition from tech towards from non-technical background to tech background, and at the same time you being able to network and work with a group of people. The most important thing that I'll let you to take away from here is that you cannot learn DevOps without doing it, like Gbemisola said. So try to do as much as you can, and with that you can always drive innovation and excellence in your respective field. So once again, I want to say thank you everyone, and have a wonderful day.
Thank you so much for having me. I really had a great time. Bye, everyone. Thank you.
Yes, thank you so much, Jamie. Bye. Bye, everybody.
Bye, everyone.
Yeah.
Take care. Enjoy the rest of the evening.
Yeah, thank you very much.
Bye.